Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we started in a previous video. We were studying about the ionic bonds, and today we're going to study the names and the formulas of ionic compounds. Our objectives for today are to define the formula unit and explain how it's related to ionic compounds composition. And number two, to practice about writing the formulas for compounds formed from different ions and oxyanions. So basically we have two new keywords. The first one is the formula unit. We need to understand what is meant by formula unit. And we have the oxyanions. Also, we need to understand what oxyanions are. In the previous video, we studied the formation of the ionic compound, how the ionic bond is formed. Basically, we had this example. For example, the sodium, it has only one valence electron. It will lose this electron to become a sodium ion, which is cation, which is a positive ion, as you can see here. And for example, the fluorine or the chlorine atoms, they need one electron because they have they have 7 valence electrons and they need to make them 8, so they will gain this 1 electron from the sodium, and then they will become negative anion. And then because the sodium ion is positive, the fluorine ion is a negative, there is an electrostatic force between them. We call it the ionic bond. I recommend you guys to go back to watch the first video, or the second video actually, before we start the names and the formulas, if you haven't watched it already. All right, what do you mean by the formula unit? The formula unit is the chemical formula for an ionic compound. We call it the formula unit, and it represents the simplest ratio of ions in the compound, the simplest ratio. So for example here, Mg, it has 2 valence electrons, and the oxygen has 6 valence electrons. Mg needs to lose these 2 electrons to become Mg positive 2, and the oxygen will gain these 2 electrons to become O negative 2, and we put number 2 underneath magnesium and number 2 underneath the oxygen. Magnesium will take number 2, oxygen will take number 2, and the compound should be Mg2O2. But here we're talking about the formula unit because it's an ionic compound. This is a metal and a non-metal. That means we need the simplest ratio of those ions. So basically we can divide by 2 here, and then the formula unit should be MgO, not Mg2O2. This is the formula unit of the ionic compound MgO. Similar thing here, for example, if you have Mg and N, N is negative 3 because it has 5 valence electrons and it needs 3 to become 8, to become more stable. And the Mg will get rid of 2 electrons. It will lose 2 electrons, so it will become Mg3N2. This is the simplest ratio. We cannot simplify it more. So it's going to be Mg3N2. This is the formula unit for the ionic compound. The last example here, Al positive 3 and N negative 3, I'm going to write number 3 underneath the aluminum and number 3 underneath the nitrogen. Aluminum will take 3, nitrogen will take 3, but we need to divide by 3. We cannot write it Al3N3. We need to write the simplest ratio between the 2 ions, so it's going to be Aln. All right, so this is the formula unit, which is the simplest ratio of the ions in the ionic compound. Let's talk now about the types of the ions. We have 2 types of the ions. The first type is called monatomic ion, and the second type, it's called polyatomic ion. What's the difference between them? The monatomic ion is an ion that is formed from only one atom, and it's like a 1 atom ion. For example, all group 1, group 2, 15, 16, and 17, they form monatomic ion, just like lithium, sodium, potassium, nitrogen, phosphorus, sulfur, oxygen, chlorine, fluorine, iodine, bromine. All of them, they form monatomic ion because they consist of, or they originally came from one atom. And because we have here group number 1, so the valence electrons are 1, just like the sodium, Na. It has only one valence electron. So after losing this one electron, it will become Na positive 1. So all group 1, they will form charge of positive 1. Mg, for example, it has two valence electrons. So it will lose two electrons and it will become Mg positive 2. So all group 2 elements will form positive 2 ions. Group 15, nitrogen, N, it has 5 valence electrons. Just like the phosphorus. Also the phosphorus, it has 5 valence electrons. And we need to gain for each, for example, for the nitrogen, we need to gain 3 electrons, so it will become N negative 3, just like what we saw it here in this example. So the charge of the ion of group 15 is negative 3. Group 16, negative 2. Group 17, all the halogens, chlorine, fluorine, bromine, iodine, are negative 1. Now, those elements are the main elements. What about the transition elements? The transition elements are the elements located here. You see, those are the transition elements. Those elements, mostly, they have more than one oxidation number. For example, in group 4, we have the titanium positive 2 and titanium positive 3. Group 5, we have vanadium positive 2, vanadium positive 3. Manganese positive 2 and manganese positive 3. Iron positive 2 and iron positive 3. Cobalt. We have, for example, the copper positive 1 and positive 2. The same copper, but different ions. For example, mercury, we have Hg2 positive 2 and Hg positive 2. So the elements, the transition elements, most of them, they have more than one oxidation number or more than one ion. Could be positive 1, could be positive 2, etc. All right. So in the monatomic ion, it consists of only one atom. It comes originally from one atom. Some of them, they have only fixed number of charge from group 1, group 2, and then from 15 to 17. And the transition element or transition metals, they have more than one oxidation numbers. The second type of the ions, we call it the polyatomic ion. Poly, it means many. And this ion or these ions, they are made up of more than one atom. If you check this table, look at the charges. All of them are negative, except for the NH4. NH4 is the only polyatomic ion which is positive, and we call it the ammonium. And it's positive 1. Actually, those polyatomic ions, we need to memorize them, but I never ask my student to put the table there and memorize them. We memorize those polyatomic ions very easily by practicing. When you repeat practicing, finish, you will memorize those polyatomic ions. They are very important, not only for grade 9 or grade 10, but also for more or higher grades. Grade 12, they are now studying the acids and bases. If they don't know the polyatomic ions, they are in big trouble. So this polyatomic ions is very, very important for all sections in chemistry. Now, for example, we have the nitrite, ITE, because it has two oxygens. And we have the nitrate, ATE, because it has 3 oxygens. So these two are like couple, nitrite and nitrate. NO2 negative 2 is the nitrite, NO3 negative 1 is the nitrate. Hydroxide is very important polyatomic ion. It consists of oxygen and hydrogen with a negative charge. Permanganate, MnO4 negative 1. Also, it's very important. Hydrogen carbonate, look at it, HCO3 negative 1, hydrogen carbonate. And also we have the carbonate, which is CO3 negative 1 without hydrogen. So hydrogen carbonate and carbonate. These 4 are very important. Usually they come in the exam. We have ClO2 negative, just like the NO2 negative. It's chlorite, ITE. And the ClO3 negative, just like the NO3 negative. This one is nitrate, this one is chlorate. But the one before ClO2 negative, we call it hypochlorite. Hypochlorite. And the one after ClO3 negative, we call it perchlorate. So we have hypochlorite, chlorite, chlorate, perchlorate. We have here, for example, the this one, it means 2, dihydrogen phosphate, because PO4 alone, this one, it's called phosphate, and it's negative 3. H2PO4 negative 1 is diphosphate. And we have the hydrogen phosphate, which is only one H, not dihydrogen, only hydrogen phosphate. So it's going to be HPO4 negative 2. Also, we have the sulfite, which is SO3 negative 2, SO3, just like NO2 negative 1, nitrite, sulfite. And when we have more oxygen, we call it sulfate, ATE. Here, when we have more oxygen, we call it nitrate. So sulfite, SO3 negative 2, nitrite, NO2 negative 1, sulfate, SO4 negative 2, and nitrate is NO3 negative 1. We need to do more practice about those polyatomic ions because, as I told you, they are very, very important. Not only for the exams, but for next sections. All right, now, how to write the formula for binary compounds. Binary compound, it means only 2 ions. One positive and the other one is negative. Both of them are monatomic ion. It means they consist of only one atom ion. Let's check this example. Write the formula of the ionic compounds made from potassium and oxygen. Now, the first step is to look at the periodic table. I know that potassium is in group 1. That means it has 1 valence electron and it will become potassium positive 1. If we forgot about this, let's write potassium from the periodic table, K, which has 19 electrons, atomic number. So I'm going to write the electron configuration. So it's going to be 2, 8, 8, and 1. This is 19 electrons. And number 1 here is the valence electron. So it's going to lose 1 electron to become K positive 1. Oxygen, it's in group 16. That means it has 6 valence electrons and it needs to gain 2 electrons to become stable. That means it will become O negative 2, oxygen negative 2. Or we can write the atomic number, which is 8, and it's going to be 2 and 6. I have 6 valence electrons, so I'm going to gain 2 electrons to make them 8. After gaining 2 electrons, it will become O negative 2. Now, whenever we need to write the ionic compound, we always start from the positive ion and then from the negative ion. It means the positive ion is always on our left hand. The negative ion is always on our right hand. So I'm going to start K, positive, and then the oxygen is -2. I'm going to write number 1 under the potassium, 1, number 2 under the oxygen. K will take 2, O will take 1, so it will become K2O. This is the compound, the ionic compound formed from the potassium and the oxygen. Later on, we will try to name these compounds. Number 2, magnesium and chloride. So magnesium from the periodic table, it has 12 electrons, or it's in group 2. That means we have 2, 8, and 2. Losing 2 electrons, it will become Mg positive 2. So losing 2 electrons. For the chloride or the chlorine atom Cl from the periodic table, it has 17 electrons. It's going to be 2, 8, and 7. Needs only to gain 1 electron, and it will become Cl -1. Now I'm going to start writing Mg positive 2, Cl -1, and then here positive 2, negative, without the charges, I'm sorry. Number 2, number 1, Mg will take 1, Cl will take 2. The compound is MgCl2. Last one, sodium and phosphate. Now, phosphate here is a polyatomic ion, which is PO4 -3. And the sodium is Na, and we know that the sodium is in group 1. That means the oxidation number or the charge of this ion is +1. I'm going to write 1. 3 is going to be Na, 3 PO4, and that's it. Look here, all the compounds, the ionic compounds, they are neutral. They don't have charges, no charge. No charge and no charge because they are compounds. But this one is not a compound. It's a polyatomic ion because it has a charge on it. And it's PO4 -3 for all the ion. It acts like one unit. All right. Now, the last example, write the general formula for the ionic compound formed by elements from the two groups shown. Basically, we have group number 2 and we have group number 17. I'm going to give the elements of group 2 X and group 17 Y to write the general formula for it. It's a challenge question. Now, in group 2, we know that we have 2 valence electrons. So it's going to lose 2 electrons to become X +2. And Y, because it's in group 17, that means it has only 7 valence electrons, not only, too much. We have 7 valence electrons, so 1, 2, 3, 4, 5, 6, and 7. So to make them 8, according to the octet rule, we need to gain 1 electron. So it's going to gain 1 electron. And after gaining 1 electron, it will become Y -1. Don't forget, we write positive, then the negative. So I'm going to start with the X. X +2 and Y -1. I'm going to write number 2 here, number 1 under the Y. X will take 1, Y will take 2, and it will become X, Y, 2 is the general formula for the ionic compound consists from or formed by atoms from group number 2 and atoms from group number 17. Ions from group number 2 and ions from group number 17. I hope you guys understood this because our next example Before our next example, I want you guys to pause the video and practice to do an ionic compound formed by any metal with any non-metal. For example, you can take the sodium with the sulfur, or you can take the magnesium with the phosphorus, and then you can take the aluminum with the chlorine. You can do the aluminum also with the phosphorus or with the sulfur, etc. It's up to you. Just practice to do the ionic formula by these elements of period number 3. All right, let's continue. How do we name the ionic compounds now? We have 5 rules. They are very simple. Name the cation first, followed by the anion. So for example, if I have NaCl, this is the table salt, we name the cation first, which is sodium. No change for the cation. And then we need to name the anion, but I'm not going to write sodium chlorine. This is incorrect because we have a rule for this. For monatomic cation, use the element name. So this is Na positive, it's sodium, we use the element name, no change. For the monatomic anion, the negative one, this is the positive, the negative one, use the root of the element name plus IDE. This is the main rule. So I cannot write chlorine. I'm going to write the root of the element, and then I'm going to add IDE. And we all know the sodium chloride, the table salt. So the name now, it's sodium chloride, not chlorine. Number 4, indicate the oxidation number by writing the Roman number of the cation, the positive one. Basically, this one is for the transition element because those elements, they have more than oxidation number. For example, for Cu could be positive 1 or could be positive 2. It depends on its oxidation number. We will have an example about this. Now, when the compound contains polyatomic ion, it's very simple, name the cation, the same thing, sodium, followed by the name of the polyatomic ion. As simple as this. Let's do some example and we will check all those rules. NaBr. Na is the cation, Br is the anion, it's monatomic ion, so I'm going to write sodium. And this is the bromine. We change the bromine, we take the root of the bromine, so I'm going to write bro. And instead of INE, it will become IDE. So it's going to be sodium bromide. This one, calcium, no change for the cation. And this one, instead of chlorine, it's going to be chloride. Now, here we have polyatomic ion. And this polyatomic ion, OH negative 1, is hydroxide ion. And this is a potassium, so it's going to be potassium hydroxide. So always the first name is the cation. The last name is the anion. Here I have CuNO3 2. But don't forget, NO3, the nitrite, is negative 1. And here I have Cu, and then I have 2 of it. So to balance it, this copper should be 2. Because if I write number 2 here, number 1 here, copper will take 1, nitrite will take 2. So it's going to be copper nitrite. But which copper? Because we have copper positive 1 and copper positive 2. This one is copper positive 2. So I'm going to write copper. Then the Romanian number 2, and then nitrite. Last example, this polyatomic ion, CrO4, is the chromate. And then the Ag is the silver. So it's going to be silver chromate. I know that you will find it's too much memorizing, but I promise you, if you practice like maybe 2 examples every day, you will memorize them. You will never make a mistake about them. All my students in grade 10 and 11, they never make a mistake about the polyatomic ions and the ions. I hope you guys learned something new today. If you have any question regarding naming the compounds or the formula unit, please write it in the comment. I will read all the comments and I will reply to you as soon as possible. Have a nice day. Bye-bye.